Like I said, our last new notes for the semester. Today's objective, we're going to graph a system of inequalities. And we're going to understand what their solutions mean. So, a system of linear inequalities is a system in two variables consists of at least two inequalities in the same variables. The solution of a linear inequality is an ordered pair that is a solution to all inequalities in the system. Which means it needs to satisfy every single inequality at once, right? When we need a system of equations, we've been doing this whole unit, they need to satisfy all of our equations at once. A solution for an inequality needs to satisfy all of the inequalities at once. So if you look up here, there's some of them graphed on here. You'll notice the first two have three inequalities graphed on them. There's three different lines. We will not be doing that. We will only have two. We'll have two inequalities at most with two variables. So we are going to look like multiple lines with different pieces shaded. The key is, our solution for an inequality is where it's shaded, right? Well, if it's a solution to our system of inequalities, it needs to be where they are all shaded, or where they overlap. Alright, so that's our big key here. That's what we're going to see in the next problem we do, and in all the problems we do from here on out. Is if it asks for a solution, you have to pick one from where it's double shaded, or where they overlap each other. So, that's not what I want. There is... I'm missing a slide. Oh boy. What happened to it? Alright, give me 2 seconds. Get a snag in the action here. One. We're going to try this again. Let it load. What happens? It just disappears. Did you get rid of it? Did you delete it, Bryce? I'm watching you, man.
Wait, so we are having a test on Tuesday?
What's up?
We are having a test on Tuesday.
Tuesday next week, yeah. Alright, let's try this again. Alright, here we go. This is what I was looking for. So, do the following points satisfy the solution set? What that means is, we're looking at these points they give us. Are they in the double shaded region? Are they a solution to my set of inequalities? Well, you'll notice that there's a dashed line with green shading, and there's a solid line with blue shading. This little piece down here is where they overlap. That's what we're looking for. Are these points in that double shaded region? Now, in your paper, it's a lot harder to see, so if you want to look up on my board, you can. 0, 0. If I look at 0, 0, it's right here. Is that a solution to this set?
Yes.
No.
Wait,
Right? It's in the green, but it's not in the blue. It's got to be in both, right? So no. What about 0, -6? So down 1, 2, 3, 4, 5, 6. Ooh.
Yeah. Yes.
Yes.
But it's on the line.
Yes.
Yes. Yes. No. Yes.
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 Is it yes or no?
Yes, yes,
Are you asking me a question or you're telling me?
Yes. Maybe.
Why do you say yes? Someone explain to me why you're saying yes. It's on the line. Argue with me. Tell me why I'm wrong.
It's the line between.
What's that?
It's in the middle of the blue and green.
Well, it's in the blue and green, okay, but it's on the line.
It's on the line of the blue.
It's on the line of the blue one though. Does that count? We talked about this, right? Argue with me. Tell me why I'm wrong.
Wait.
Tell me why I say no because it's on the line. Why am I wrong?
I don't know. If it's on the line, because it's always no.
What did you say, Will?
If it's on the line, then it's always no.
You'd be agreeing with me. I don't want you to agree with me. I want you to tell me I'm wrong. It has something to do with what type of line it is. It's a solid line.
Straight line.
What do you know about the solid lines compared to the dashed lines?
Not equal to.
It's or equal to, right? The solid lines are or equal to, which means if it's on a solid line, you can include it. If it's on a dashed line, cannot include it. So this is a yes. That's why I wanted you to argue with me. I wanted you to tell me I was wrong, right? It's on a solid line, which means it's included. So yes, it is a solution. Negative 6, 0. 1, 2, 3, 4, 5, 6. Over here.
No.
No, not the blue. Alright,
Wait, are we supposed to mark these points or no?
you don't have to, no, I'm just putting them up there so you can see them. 1, 2, 3, 4, 5, 6. 1, negative 7, down here.
No.
No! It is only in the blue, it's not in the green. No. Lastly, negative 2. Negative 7.
No.
Yes.
Yes.
Yes, this one is, because you can see the green lines right here.
Oh, yeah.
So over here, so yes, it's in the double shaded region. So these next few problems, when we actually graph them, and it says name one solution, you just gotta pick one that's in the double shaded region, alright? Cool. Let's try some of these. Graph the following system of inequalities, give one possible solution. So, you are not expected to graph them both at the same time. Take it one at a time. Alright, so let's look at the top one first. Y greater than 4x minus 3. If I want to graph this, my slope is going to be 4 over 1. My y-intercept is going to be negative 3. So I'm going to plot that. Negative 3, up 4 over 1, up 4 over 1. Now, look at it. Am I going to have a solid or a dashed line for this top equation?
Dash. Dash.
Dashed, right? It's not or equal to. So I'm going to put a dashed line in there. And then I'm going to put a test point in to see which side should I shade. So test point, 0, 0. I get 0. Greater than. What's 4 times 0?
0.
0 minus 3 is 0 greater than negative 3.
Yes. No. No.
Yeah, it is. You tell me negative 3 is bigger than 0?
Yeah.
No, 0 is bigger than negative 3. So we're going to shade the side with 0, 0. Now be very careful. Notice, I'm not completely shading it in. I'm just drawing some lines. You can do it lightly, you can put a few lines. But I'm doing that because when I get my double shaded region, I need to darken that up so that I can actually see where my solution set is. Alright, so you need to be able to tell the difference between your each shaded piece and the darkened piece where they overlap. Alright, let's do the second one. Y is greater than or equal to negative 2x plus 3. My slope would be negative 2 over 1. My y-intercept would be 3. So I'm going to go up there. Shut up. At 3, it's down 2 over 1. Down 2 over 1. Down 2 over 1. This second line of mine, the bottom one, is it solid or dashed? Solid, right? It's or equal to. So solid line going through here. Same thing, we got to figure out which way am I shading. So take a test point. 0, 0. 0 greater than or equal to. Negative 2 times 0 is 0 plus 3. Is 0 greater than or equal to 3?
No.
No, that is false. We're going to shade the opposite side of our solid line. Now, do we see where they overlap? Can you see where they overlap?
Yeah, the top.
Yeah, this top piece right here, right? They both shade. You need to go ahead and darken that up. So I can tell where your solution set is. I need to be able to tell the difference between just the normal shading and that darkened piece, which is why I only did kind of lines over here. Right? So darken that up, tell me that's your solution set. Alright, because they overlap right there. And then it asked us, give one possible solution. So, Aiden, could you give me a possible solution for this problem?
Yeah, sure. 1 and 3.
So 1, 3. Perfect. The point right in the middle there. Are there more than just 1, 3 as a solution? Yeah, there's plenty of them. You can pick whichever one you want. Okay. Does that make sense?
Yes.
What we just did? Yes. You meant
2 and negative 1 gonna work?
the 2, negative 1 here?
On this line?
It does not. Even though it's on this line, is it part of this shading over here?
No.
The red one? So if you pick a point like 0, 3. That point is on the line, and it's in the red shading, so that would work. Just because it's on the line doesn't make it work, though. It's got to be with both of them. Does that make sense? Okay. All right. That's a good question. Any other questions?
No.
Do you want to try the next one on your own?
Sure.
Sure. Do it. Go ahead. I'll give you like 2 minutes and we'll reconvene. And I'll answer some questions or I'll go through it even. And we'll do the last one together. We only have 2 more. That's it. 2 more problems, we're done for the semester. Oh, man. Nice fun when you're having flies. Well, yeah, like how would you graph, like y equals -2? What type of line is that going to be? Okay, but like if you look, so you plot a -2 and then put another one here?
Oh, no.
Oh, no, that's good. Because y is -2 there, isn't it? Well, isn't y -2 over here? And over here?
Oh, wait. Oh, yeah.
So it's going to be a horizontal line. So it's just like y equals
So this is
-2.
wrong right here.
That point's wrong. Okay, so that bottom equation is going to be a horizontal line. Yep. Well, you can do the first one. Try mine. You get started.
Yeah, what's his name?
No, I get you.
The straight edge? Hey, I can hook you up with that. I know a guy, Sam.
You know that?
I know a guy with straight edges.
What's his name?
Can't tell you. Can't give away my secret source. He's ninth or well. You don't need to be. Yep. How we doing? We good right now?
Great.
All right, we'll give you 1 other minute.
So hungry.
Yes, sir.
Oh my god. Why did you shake that?
What's that? So, he's got false, right? So you go over here. This one is true, so we go up here. So if we shaded, what is this? So you shaded this piece, right? And you shaded this piece. Where do they overlap? Here, right? Because they both shaded in this spot.
Because they have
This okay?
Wait, Mr. Eldridge,
Yep.
when we divide by negative, we flip the side.
Correct. Alright, let's go through and do this thing. Y greater than or equal to -5x plus 3.
Solid line.
Solid line. Slope of -5 over 1. Y-intercept of 3. So at 3 I put a point, down 5 over 1. Bryce told me it's a solid line. I'm going to believe him. Solid line. Alright. And I gotta figure out which way I'm gonna shade. So I do a test point. 0 greater than or equal to 0 plus 3. Is 0 greater than or equal to 3?
No, so you're gonna sit on
No.
the right side.
Opposite of 0, 0, we're gonna shade. Alright, the next one's a little tricky. Remember, we're pretending this says y equals -2. Well, where does y equal -2?
Everywhere.
They go from here.
Oh, okay, okay. Wait.
So I plot -2 in y-axis. Where else does it equal -2? Like right here?
No, on the other negative two. Right?
Here?
Yeah.
That's x equals -2. If I gave you the point -2, -2.
Finishes right there.
-2, negative, right here.
Oh.
Y is -2 here. Y is -2 there. Y is -2 there. What type of line am I going to get?
Horizontal.
A horizontal line, right? Everywhere where y equals -2. So it's a horizontal line. Dash or solid?
Dashed.
Dashed. Good. Dashed line. Alright. Test point. Figure out which way I'm going to shade. 0 greater than -2. Is that true? Yes, it is. So I'm going to shade with 0, 0. Alright. Can we see where they overlap?
Top, right?
That top right portion, right? Right up here. So we shade it in nice and dark so we can see that. And that's going to be our solution then. Alright. I need Bailey to give me one possible solution for that graph. One solution where they're both shaded.
Or 3 and
3 what?
3 and
3,
3.
3. Perfect. And anything in that double shaded region. That will work. Alright. Any questions? Alright, let's sprint through the last one quickly and we'll be done. Last one, they're both given to us in standard form. So before we can do anything,
We need to change that.
we got to change it. X plus y is greater than 2. Subtract x. Y greater than negative x plus 2. So, y-intercept at 2. Slope of negative 1 over 1. What type of line am I going to have here?
Dashed.
Dash. It's not or equal to. So, red. Alright. Figure out a test point for your shading. Test point. 0, 0. I get 0. Greater than 0 plus 2. Well, is 0 greater than 2? No. That is a false statement, so shade the opposite side.
Yes, sir.
Our second equation. Same thing, solve for x, or excuse me, solve for y. Negative y. Greater than negative 2x plus 1. Hey, do I want negative y or positive y?
Positive y.
Positive y. So how do I make that positive y?
Divide by negative y.
Divide by a negative 1. So it makes positive y, but hold on. What happens to my sign when I divide by a negative? It flips. So it becomes less than 2x minus 1. Alright, so let's try and graph this. Y-intercept at negative 1, up 2 over 1, up 2 over 1. Solid or dashed line?
Dash.
Dash.
Dashed again, it's not or equal to. And same thing, figure out your test point. 0, 0. 0 less than 0 minus 1. 0 is less than negative 1. Is that true?
No.
No. So I'm going to shade the side opposite 0, 0. In which case, this whole chunk over here is my solution, because they both shade in there. Then I'm going to take, I'm going to look, I'm going to see, well, 4, 0 is my solution. Okay, anything in the double shaded region will work. Alright, any questions on that? Speak now, forever hold your peace. Sweet, homework time.